Okay, 6.6, we're going to talk about trapezoids and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. The non-parallel sides are called the legs. Base angles are two angles that share a base. So if these are my parallel sides, then this would be one base, this would be another base. These are my non-parallel sides, so this would be a leg, this would be a leg. So 2 and 3 are a pair of base angles. And then 1 and 4 are a pair of base angles. I would not want to put 2 and 4 together because they're not sharing a base. An isosceles trapezoid is a trapezoid with legs that are congruent. I drew a picture kind of an isosceles trapezoid up above, but you could have, like this could be a trapezoid. I've got one pair of parallel, so the bases are parallel. These sides are not congruent, so it's not an isosceles trapezoid, okay? So an isosceles trapezoid has the legs being congruent. All right, this theorem says if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So if then 1 is congruent to 2. I could also say, like, if I had 3 and 4 up here, then 3 would be congruent to 4. Okay? There's a proof for that in the book if you're interested. All right, find the measures of the remaining angles. So, I mean, it's still a quadrilateral, so you still know they all add up to 360, but this is 106 here, so that means the measure of angle S is also going to be 106 because it's another base angle. These two angles right here, these lines are parallel, so then these are same side interior angles, so they're going to be supplementary. But then Q and P are going to be the same thing because they just line up there. So if I do 180 minus 106, I'm going to get 74. So both of those are 74 then, 74, 74. All right. This theorem 620, if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So if we have that, then AC, so if I drew in those diagonals, would be congruent to BD. So an isosceles an isosceles trapezoid, those diagonals end up being congruent. Okay. Next thing is something called the mid-segment of a trapezoid. So the mid-segment of a trapezoid, it's the segment that joins the midpoints of the legs. So if a quadrilateral is a trapezoid, no, I didn't say it has to be isosceles here, then the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the lengths of the bases. It's a terrible trapezoid. A, B, C, D. So again, whatever the midpoint is, let's call it E. Whatever the midpoint is over here, let's call it F. So we join them together. So EF is parallel to AB, which is parallel to DC. So all of those, that mid-segment, those bases are all parallel. And then it says EF is half the sum, so I'm going to add the two bases. Remember, when I'm talking about length, I don't put that segment notation on top. Okay? So in this one right here, it says M is the mid-segment of the trapezoid. Find X, find MN. So I know that 2X plus 11 is equal to half 10 plus 8X minus 12. I can combine like terms here. Some kids don't like to deal with that 1/2. Like you can distribute the 1/2. You could get rid of it by multiplying both sides by 2. If you multiply both sides by 2, like these end up canceling. So you just would have 8x minus 2 over here, but here, this is a multiplication symbol, not an x. So here you'd have to do 2 times 2x, so you'd have to get 4x. 2 times 11 would be plus 22. So then I could work out the math there. So 24 is equal to 4x, so then x ends up being equal to 6. And then mn, when I plug it back in, 2 times 6 plus 11, so 12 plus 11 gives me 23. So that's the length of mn. All right, a kite is a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. This one's kind of funny because it says consecutive sides, but it's truly not consecutive. I mean, it is consecutive, but it's not all the consecutive. So like this one right here, these 2 sides are consecutive, so they're congruent in a kite. These 2 sides are consecutive, they're congruent in a kite. These 2 sides are congruent, but they're not consecutive. I'm sorry, those 2 sides are consecutive, but they're not congruent. I said it backwards. I could draw the kite this way too. Okay, but you notice here my opposite sides are not congruent, okay? Theorem 622 says if a quadrilateral is a kite, then its diagonals are perpendicular. So if you know you have a kite, then these diagonals are going to form 90-degree angles. Okay? So in here, if I want to find the measure of these angles and it's a kite, the measure of angle 1 is going to be equal to 90. This is also 90. This right here, so if this is 90, this is congruent to each other. This is also congruent to this one. So then these 2 triangles are congruent by HL theorem. So this 36 right here, that makes 3 also 36. So then you just have 180 minus 36 minus 90 to get the measure of angle 2. So we get 54 there, okay? All right, let's look at a couple of these homework problems. Let's see here. Oh, just before we look at the homework problems, just since I'm looking at this chart here, this is on page 393 of your book. So like just thinking about the different types of quadrilaterals that you learned. You have a quadrilateral. If you have 2 pairs of parallel sides, then then it's considered a parallelogram. And under the parallelogram, we can classify things. So you can classify a rectangle, a rhombus, a square. If you have 1 pair of parallel sides, it's a trapezoid or isosceles trapezoid. If you have no pairs of parallel sides, it's a kite. They all have different properties. Remember, like a rectangle has all the properties of a parallelogram, but then it has some extra properties as well. So you might find it useful to make a chart and kind of list all the properties that you learned. Like, you know, consecutive angles are supplementary, opposite angles are congruent, the diagonals bisect each other, the diagonals are congruent, you know, all those things that we talked about for all those different shapes. It might be, you might find it useful to make a chart and put them all together. All right, I'm trying to find one that's not too easy, but yet not too hard. Some of these ones here, the underlined ones are proofed. The ones in parentheses, they're optional. They're actually, this one right here is especially hard. You can find the answer on Schoology. All right, let's look at number 36, because it's kind of a weird one. So in 36, so I have a kite here in 36, and I know in this one that this is a 90-degree angle up here, and in the kite, these 2 triangles that are created here are congruent, so these little angles are the same. They're half of that 90-degree angle. So I have a 45-degree angle up here at the top. I have 6x here, and then I have 3x over 2 here. So that would equal 180 because it's a triangle there. What you're going to have to do here, I'm going to subtract the 45. So I have 6x plus 3x plus 2 is equal to 135. Then what's going to be easier for me to do is there's a fraction here, so I need to change this to 12x over 2. I'm going to combine them now together. Now I can multiply both sides by 2. When you multiply 135 by 2, we get 270. Then I can divide 270 by 15, and I get 18. And then once I have that x is equal to 18, then I could go back and plug it back in. So 6 times x, so 6 times 18 would be 108. So then y is equal to 108. So x is 18, y is 108. All right. And some of these proofs, you're going to have to like add a line. So like I'll look at 46 here with you. So number 46, it says prove the converse of theorem 619. If a trapezoid has a pair of congruent face angles and then the trapezoid is isosceles. So in this one, there's not going to be anything like this on the test where you have to like construct something, but so I drew a trapezoid ABCD. And I said make trapezoid ABCD with congruent base angles and base BC is parallel to AD. Okay, so that's just defining it. That's just what I'm giving there. And then my goal is to try to show that ABCD is an isosceles trapezoid. So I need to show that both BA and CD are congruent to each other. And I mean, you could try to slice it up and make a triangle inside, but the way that this proof is kind of done is that they put a point out here and they extend AB and CD to meet E. So I'm doing like a sort of construction here. And then it doesn't look like this in the picture, but I set it up so that AE would be, well, it doesn't look like this picture, but since these two angles down here are congruent and I have a triangle right here, again, this doesn't really look like it, then AE has to be equal to DE because of the converse of the isosceles triangle theorem, so if your base angles are congruent. So AE is equal to DE. I also know here that these lines are parallel, so these angles, this angle and this angle are congruent, and this angle and this angle are congruent because they're corresponding angles. But then I also know that these two just are congruent to each other because these were already congruent to each other. So I just wrote here, I wrote parallel lines where the corresponding angles are congruent. I kind of am jumping around here, but this is already long enough, so I'm just kind of condensing it. Again, you're not going to have any proofs in the test where you have to add a line to construct. So if I know that these angles are congruent, then I know the opposite sides are congruent, are equal or congruent because of the converse theorem. I also know that AE is equal to EB plus AB, and I know that ED is equal to EC plus CD because of the segment addition postulate. I said back here AE was equal to DE. I said that over there. So then I'm just substituting DE in for AE. But now if you notice I have DE and ED, which are the same segment. So then I'm substituting those two to each other. And then I'm doing the subtraction here. So I get AB and CD. So AB is equal to CD. So I already knew that I had one pair of parallel lines. I drew a trapezoid intentionally. So now it's an isosceles trapezoid because of the definition of isosceles trapezoid. All right. Again, these proofs are just, they're kind of weird, but there's nothing on the test where you're going to have to construct anything, so don't worry about that part, okay? That's it for this